In this video, we're going to make 8-bit AND. It takes two 8-bit operands and generates one 8-bit result, which every single bit of the output corresponds to the AND of the inputs. So let's start by dropping AND gates. So we need 8 AND gates. If you double click on the symbol, you can drop instances by single click. Okay, that's 8 gates. From schematic, I insert 2 breakouts for my 2 8-bit inputs. As always, I'll name my breakouts or bus A0.7, which is an 8-bit bus. So that's the first input, that's the second input. We also have an output. I'll leave the breakout for output here. And then I'll start attaching inputs. Okay, all input and output buses are connected. Let's derive some inputs and test the correctness of the circuit using some values. To be able to drive every single pin of the bus, we need to attach a breakout to the other side of the bus as well. One breakout for first input, second breakout for the second input. Drag the buses a little bit down to see if this is actually connected to the buses, to the breakout or not. Let's name the signal, name the buses. We have bus A, bus B, and this will be the result. Let's call it S. Okay, we need to drive in 16 inputs. The best way to driving that amount of data is probably to use a hex keyboard. Use a hex keyboard. To make sure hex keyboards are connected, select all the hex keyboards, use arrow keys to move them left. And if the wire is coming with the hex keyboard, that suggests the signals are connected. Start the simulation. And then from simulation, enable show value. So you see what values are on every one of the signals. So if the input is 0, 0 hex for A and B, the output is 0, 0. That is the expected result from AND. If one of the input is FF, the result should remain 0 from basic operation of AND. Let's say if one of the inputs FF, the result will be equal to the other input. So for instance, if we set the other input to 1, 0, the result should be 1, 0. We go over 7B, for instance, the result should be 7B. So that confirms the circuit is working as expected, and we can save this one. So that is done for the first part. This is the second component I'm making. I'll create second folder 02 and name this file as and 8. Okay. The next step is to create a symbol from this circuit. So I'm going to save this file as a symbol. So You see the name of the file and a symbol. This is identical to the other file. And here we're going to replace all the drivers with ports. So I'm going to remove the breakout, going to remove the drivers, and going to replace them with ports. Okay, I need 2 input ports and 1 output port. We need a bus version of the port. We can't use the standard port that is provided by the library. We have an extra library that we import for getting access to bus ports. We can find the library in the description of the video. When you extract the library, you get access to CSCI 250.clf, and you can open this library. If you inspect the components in this library, you see 1 port in 8 and 1 port out 8. Port in 8 is what we are going to use here. Okay, 2 port in and 1 port out. Okay, I'm going to save this file. So you see a message that says there are unnamed ports. So let's name the ports and then we continue. Let's name the ports. Use letters for picking a name for your port. Don't use space or special characters or numbers. Okay, that's all the ports. Let's save the file again. Now there is no error in saving the file. Let's create a symbol. File, new device symbol. And here we first specify the implementation. When you attach the implementation, the only open circuit, you will see AR input, B signals are input, and S signals are output. This is what is expected. Then we generate a symbol shape. Let's call the symbol AND8 and move the outputs to the right side in the standard form, and then we generate the symbol. Okay, that's how the symbol looks like. Let's save the symbol in a library. Okay, I'm going to push this new symbol into my existing library that I created for CPU project. Okay, I open the existing library and then library will show up in destination libraries. I select the library and then press save. And this new symbol will be added to the library. Okay, that's the end of the second step. The last step is to verify that the newly created symbol is working as expected. So create a new circuit, instantiate this symbol, and put the breakout. And then select hex keyboard to derive some inputs. It's pretty much same thing we did for the first step. We derive some inputs and verify the correctness, but this time we don't see the internal implementation. We only verify the symbol. Let's start the simulation, and from simulation enable show value. Okay, 0, 0, output is expected to be 0. Let's try F, and any value for input A should be the result. So 1 is the result, 2, 0 is the result, 3, 3 is the result. So that confirms the circuit is working as expected, and we have added and 8 to our library. You can save this file as testbench.cct.